Good morning to one and all present here. It is my pleasure to welcome you, all of you, for the Viva voice of Amsaveni, our department part-time research scholar, joined 2017. Today, she is going to present her Viva titled "A Hybrid Technique to Improve Parallel Nonlinear Dimensionality Reduction Using Semi-Supervised Learning." First I welcome my HOD, Dr. Geeta ma'am, and my friend and my motivator, Dr. Surendran sir from NIT Vishwari, Karakal. Welcome sir, welcome ma'am. And I welcome my faculty colleagues, Pankaj sir, Kumar sir, and all other Nandini madam, and all other my friends. HOD ma'am, can you give some word? Then she will start a presentation.
A warm good morning to one and all gathered in this virtual platform. It is indeed pleasure for us to have Viva voce of our department faculty, Dr. S. Dureisamy, his candidate, Mrs. Amsaveni, on behalf of the college and on behalf of the department. I extend a warm welcome to today's external examiner, Dr. B. Surendran sir. Sir, hearty welcome, sir.
Thank you, madam.
And also let me welcome all the allied faculties, HODs, professors from various departments, various colleges for this Viva voce meeting. Let me also welcome my own department colleagues, friends, and our own staff from various departments of our own college. So on behalf of the college and on behalf of the department, once again, let me welcome one and all. So let us enrich this Viva voce experience. Also, let me extend a warm welcome to all the scholars, all the students of my college, of our department, and other students and scholars of various institutions. Also, let me welcome today's scholar, Mrs. Amsaveni. Wish you all the best on behalf of Alma.
Okay,
thank you. Thank you for the opportunity, sir. Thank you, sir.
Thank
Over
you.
to you, sir.
Thank you, ma'am. So you can share your PPT and present your dissertation.
Good morning to one and all present here. I am Amsaveni. I'm here to present my Viva voce presentation in the topic a hybrid technique to improve parallel nonlinear dimension reduction using semi-supervised learning under the guidance of Dr. S. Dureisamy sir, Assistant Professor, Department of Computer Science, Chikkanna Government Arts College. And I extend my warm welcome to Dr. V. Krishnan sir, Principal, Chikkanna Government Arts College, Tirupur. And also I would like to welcome external examiner, Dr. Surendran sir. Happy to welcome you, sir. And I welcome Dr. E. Geeta ma'am, Assistant Professor, Head PG and Research Department. I express my sincere gratitude to Dr. C. Chandrasekhar sir for his valuable comments, which helped me in completing my thesis work. So I would like to welcome faculty members, research scholars, and my fellow students. Welcome you one and all. At my presentation.
Sir, excuse me, ma.
Share pandra.
Sir, just a minute, sir. I'm sorry. Let me also welcome our beloved principal, sir, Dr. V. Krishnan, to participate in the discussion of this Viva voce meeting.
Thank you.
We heartily welcome you, sir. Thank you.
Thank you.
Sir, madam, sir. Sir, ungaloda words, sir, please. Principal, sir.
Sir, வணக்கம். வைவாவை வந்து நீங்க நடத்துங்க. நான் அவங்க பேசுறது கேட்டுட்டு அதுக்கப்புறமா ஏதாவது ஒரு நான் சொல்றதா இருந்தா கடைசியில் நான் சொல்றேன் சார்.
Thank you.
Okay.
I start my presentation with the agenda, which consists of motivation, objectives, introduction, literature survey, research contribution, future work and references. Motivation of my research. Data is described as the aggregation of data and large voluminous of information and processing certain data mining techniques. And big data also provides information in a conventional data processing system, and it can handle and process it. So data is additionally a piece of information used in different access in the module of data. Here are the objectives of the research. To improve the efficiency of attribute reduction in big data, parallel receipt theory-based attribute reduction is proposed. And to improve the big data clustering process, parallel semi-supervised multi and clonase clustering algorithm and parallel semi-supervised multi-imperialist competitive algorithms are proposed. And to handle the imbalance problem in random forest-based big data classification, FDNN, that is Forest Deep Neural Network, is proposed. Here comes the introduction. Big data is described as a voluminous information for processing of certain data mining techniques. And the characteristics of big data are with different layers. To learn them in depth, they are volume, variety, and velocity. The volume is also known as the data amount in which the primary attributing process of big data takes place. So variety refers to the source of data and their nature. So velocity is described as the rate at which big data is produced. It can be interpreted as the time it takes to transfer the files from where it is retrieved. So importance of big data. The cost savings, when vast volumes of data need to be processed, certain big data applications can have cost saving to companies. So reductions of time because of the high speed of tools like Hadoop and in memory analytics, companies can quickly find new sources of data, allowing them to analyze data automatically and make decisions based on their learnings. Next comes the importance of big data. So understanding the market conditions, big data analysis can help to get a greater view of current business dynamics. And then online reputation, sentiment analysis can be performed using big data methods. So it is possible to get feedback about who's saying about what about the organization. Using big data to solve advertisers' problem and offer marketing insights, big data analytics can help change. So big data analytics is a method of collecting, arranging, and evaluating massive data sets in order to find valuable knowledge. Big data requires tools and methods that can be applied to analyze and extract patterns. So here we have different types of big data analytics, namely descriptive analytics, diagnostic analytics, prescriptive analytics, and predictive analytics. So the first one is the descriptive analysis. It simplifies the data and summarizes it in a readable format. So we call it as parsing historical data to better understanding the changes. So next, diagnostic analytics. Diagnostic analytics describe the techniques you will use to ask your data. So the predictive analysis, this analytical approach looks at current and historical data for making future decisions. So predictive analytics analyzes the latest data and provides potential prospects for data mining, artificial intelligence, and machine learning. So here comes the prescriptive analytics. It is the purpose to give a solution to a problem, and future analytics can be used both in descriptive as well as in predictive analytics. So most of the time, artificial intelligence and machine learning are the emphasis. So pre-processing, this is one kind of classification where it involves data cleaning, data integration, data transformation, and data reduction. Next comes the literature survey. The map, these are all the papers I have referred and done. In the year 2015, Figaro et al. He proposed the classification problem without substantial accuracy loss. And in the year 2015, Silva et al. Also reduced the size. He proposed reducing the size of dimensions of big data using SVM-based strategy, that is support vector machine-based strategy, to reduce the size. So in the year 2015, Payne et al. Hierarchical attribute reduction algorithms proposed to reduce using map-reducing algorithm. And then in the year 2016, Wang et al. So he proposed a hash map. It is a type of technique to store metadata per constructor. So in the year 2016, Malik et al. He proposed higher classification accuracy. The data points were demonstrated as a higher classification accuracy, and it is strongly adaptable in nature. So in the year 2016, Chen et al., the dynamic attribute reduction using dominance-based neighborhood rough set was constructed, and it is enhanced in the future. In the year 2017, Remers Gallego, he proposed feature selection in the high-speed data sources, analyzes the estimated selection. And in the year 2017, Ding et al., a fuzzy-based cluster algorithm has been proposed to reduce the dimensions of the data. So, and in the year 2018, Janender, Peltimer, he proposed algorithm to reduce the volume of data with simplified number of attributes, and and also the attributes are minimized using the resulting data that to be processed. So in the year 2018, Krishnan et al. He proposed mapping parameters using a low rank singular value decomposed, that is SVD. So in the year 2018, Lane et al. So he proposed a fuzzy rough collection based multi-label attribute reduction, the samples for the target sample. And in the year 2018, and et al. In this method, in this proposed method, the positive regions of the samples model was constructed in the maximal intersection with the decision trees. But in the year 2019, et al., so the enhanced SRF results in maximizing the hyperparameters and prediction accuracy was increased by reducing the dimensions. And in the year 2019, Krishnan et al., the dimension reduction technique was proposed for the normal dimension reduction methods to increase the classification methodology. And in the year 2019, and et al., for attribute reduction, a greedy convergent algorithm was developed based on trusted theory. So in the year 2020, the number of components has been proposed, namely mean squared error plot, estimating the number of components involved in the big data. In the year 2020, Reddy et al., he proposed dimensionality reduction techniques that evaluated on high dimensionality data such as images, text data, and so on. So in the year 2050, Subramania Swamy, he proposed a map reducing technique with that process massive amounts of in parallel as small chunks in distributed clusters. And in the year 2015, the hybrid Karimov, he proposed hybrid algorithm used to locate these points using centroid selection. So in the year 2016, Barrel et al. Proposed approach with a fuzzy clustering for handling big data. So techniques based survey paper. The year 2016, Safik et al. Proposed for big data clustering. And he used k-meters processed and assigned a number of data points in clustering with the k-meters. So in the year 2016, Bendek et al. He proposed a different method on a very large data set, which combines the other models for neighboring clusters. In the year 2016, EM et al. Proposed fuzzy C-means clustering to the new data set. And in the year 2016, Fahad SE, the time conception problem using k-medoid algorithm was solved. In the year 2017, Gu et al., the performance of dynamic approach dropped significantly and resulting only 3 clusters with much greater dissimilarity. And in the year 2017, Haji proposed cluster-based data partition used to manipulate the physical locality of the data to match the graph. And in the year 2018, Pang et al., so he proposed high computational cost and data dependencies. Hierarchical clustering was difficult to parallelize. And in the year 2018, the tensor canonical qualitative decomposition was used to reduce the data set to improve the clustering performance. So in the year 2019, Kumar et al., the hybrid clustering approach has the limitation of taking more time to execute k-means and hierarchical clustering methods. And in the year 2019, C-means algorithm by background verification process and prediction approach was proposed for a big data clustering model. So, and in the year 2019, Shukla proposed defuzzified data were clustered using fuzzy C-means clustering. So, using this dimension were reduced using multivariate big data sets. In the year 2020, Chen et al., the accuracy of high density information security storage in big data center was less with the problem occurs in security storage of big data center. So in the year 2019, Chikkanna et al. Proposed a priori algorithm and rule selection were subjected to comprehensive empirical evaluation to determine accuracy, complexity, and quantity. So in the year 2020, the high dimensionality redundancy information was allowed to reduce the size of the samples without affecting the accuracy obtained by the classifiers. And in the year 2019, k-means method was utilized to reduce the degree of imbalance without losing the information which are in the clusters, the majority data into the subclasses and help minority to describe the boundary. And in the year 2018, Habib, he proposed a map-reduce function that is used to split the fragments and distribute it to different mappers for checking these sensitive data. And in the year 2015, Lopez et al. He proposed the algorithm that computed different processing units to reduce the map operations for the classification system. So in the year 2015, he et al. He proposed parallel sampling hypersurface, which was applied by the MapReduce framework, measured the instability of minimal consistent subset. And in the year 2015, Zin et al. Proposed predictive learning, which was efficiently carried out with the rapidly modifying huge training data set. So in the year 2016, he proposed the approach key nearest neighbor classification in terms of efficiency. And in the year 2016, Chen et al. He proposed a real-world cloud environment where huge volume of sample blocks were situated in different modes. And in the year 2018, Sen et al. He proposed the method feature at a time and segment at a time and applies the concept to other linear machine learning models. In the year 2018 alone, proposed MPLS, multi-protocol label switching, and GMPLS for a classification technique as a core network. So in the year 2018, DABIA, the whole process of dendritic cell algorithm, which is involved in genetic algorithm, was partitioned into simple tasks and then subjected the intermediate results to finally obtain the better result. Here follows my research contribution. So the problem specification, the user-defined criterion and multi-step dimension reduction approach has greatly influenced the efficiency of attribute reduction. And probabilistic C-means is not more efficient for big data and cannot define the complex correlation over heterogeneous data objects. Random forest-based big data classification is not more efficient for imbalanced big data. My proposed work contributions, the data dimensions was reduced through a parametric mapping, and it is estimated using low rank singular value decomposition. And the big data clustering techniques introduces MapReduce technology called parallel semi-supervised big data clustering and parallel semi-supervised multi-and colonies clustering. And each mapper generates a diverse selection of 3 clustering components and is combined in the reducer. The big data classification is focused on the FDNN, that is Forest Deep Neural Network, to classify the big data. The ensembling random forest and deep neural network are combined together for the classification for the imbalance problem that occurs in big data. This is the architectural diagram of Viva, where in dimensionality reduction technique, I constructed rough set theory and parallel rough set theory. And in data clustering, parallel semi-supervised multi and colonies clustering algorithm and parallel semi-supervised multi-imperialist competitive algorithm as proposed. So, and in data classification, ensembling random forest algorithm and forest deep neural network are used for performance evaluation. The following are the research contribution. The first one is a parallel rough set theory for nonlinear dimension reduction and big data analysis. And my second contribution is parallel semi-supervised big data clustering based on MapReduce technology. My third contribution is big data classification based on forest deep neural network. This is my first contribution, and this is published in the Scopus journal. Reduction. Multi-step dimension reduction approach was proposed for attribute reduction in big data. Here, the dimensions was reduced using parametric mapping, and multi-step dimension reduced the efficiency of attribute reduction. So here, I proposed a parallel set theory-based attribute reduction approach is developed for reducing the attributes in big data. The performance of reduction is detected based on the inner and outer importance measures. By applying the process of parallel set theory-based attribute reduction, the computation time is reduced significantly. More attributes lead to a better system. However, attributes can be very complex if they do not properly cover data and classes. So the calculation time is reduced using parallel set theory-based reduction process. And the overall diagram where multi-step dimension reduction approach is carried out using parametric map, and the estimation is performed using singular value decomposition. And here in parallel rough set theory based approach, I constructed rough set theory on 2 descriptions to achieve parallel data. So the reduced attributes are given to different classifiers to classify the data. The importance of attribute reduction in big data. So the method of minimizing the number of attributes under consideration is known as attribute dimensionality reduction. The dimensionality reduction technique is used to eliminate certain features of data attributes by merging or integrating. So the dimensions of huge data sets refer to number of attribute features in the data set. And the method of minimizing the number of attributes is known as attribute dimensionality reduction. So the technique used to eliminate certain features of data attributes by using merging or integrating. The dimensions of huge data sets refers to number of attributes, attribute features in the data set. And the cardinality of the transform space is set by a user-defined parameter determining the amount of information to be captured in each group. So the group-wise organization for a reduction procedure is repeated until the particular attribute has been satisfied. Multi-step dimension reduction approach or calculated using a nonlinear relationship using distance covariance. In each group, it is the distance covariance is calculated. The features are transformed with a parametric mapping using similar value decomposition of distance covariance. The new set of attributes is reorganized into groups where loss criterion based on similar values is therefore defined. And furthermore, it is impossible to define the number of dimensions in general, which must be extracted from the data because information about their usefulness is preliminaries and distance covariance. It is a measure, distance covariance is a measure of dependence between two paired random vectors. So both linear and non-linear association have two random variables. It is desirable to reduce the number of dimensions prior to classification. Before going to classification, the number of dimensions has to be reduced and the noisy dimensions also has to be removed. So noisy dimensions in the sense redundant and to remove all those dimensions. So the measure of dependency that can be characterized in the presence of nonlinear relationship known as DC, that is a distance covariance. Nonlinear dimension reduction, the objective is to transform the data into new dimensional space to reduce the redundancies among the two attributes in the group. So singular values signify the variance of each dimension in the group. The singular values are first normalized that lie between 0 and 1. And threshold set by the practitioner, that is 98%, which refers to the percentage of information to be retained in each group. And now let us assume that in each group, the number of dimensions to be extracted is 1. The low dimensional approximation of singular value decomposition transforms the data in this group, and reduction procedure is repeated for each of the 4 groups to achieve the reduced number of dimensions. To control loss of information, this average of singular values verified after each step of dimension reduction is using criterion method. Let the average of singular values after first step be 0.98%, which implies that 90% of the information is retained out of 100%. Since the threshold value is set to 95%, information loss condition is not satisfied yet, and therefore two-dimension reduction procedure is to be initiated. So the first objective is to group the attributes and are grouped according to the strength of singular values. And using the grouping mechanism, two groups can be constructed for our example. The first attribute belongs to the same group as the third attribute. Furthermore, the second and fourth attributes form the second group. The two stages of the proposed procedures are continued to the singular value condition phase. So the dimension reduction procedure is repeated for 2 stages in the example, whereas the second transition, which is less than 95%. So non-linear dimension reduction of the overall technique has reduced the number of dimensions from 8 to 2 at the end of the 2 stages. So next comes the rough set theory. It is a data mining or knowledge discovery technique used in relational databases. So in the basic form, it is a modern branch of uncertainty mathematics similar to fuzzy theory. Rough sets have a stable platform for knowledge discovery. It provides mathematical tools for detecting the hidden patterns in the data. So it can be used. It can also be used to select features or extract features, reduce data, grade decision rules, and can also be used for used to extract patterns. So it detects partial or absolute data dependencies, removes redundant data, and provides solutions for null values, even the incomplete data, complex data, and other issues. So in rough set theory, when the data is compiled in a table, it is known as a decision table. Rough set theory divides the entire process into 3 different regions, namely lower approximation, and boundary region. So the boundary region is the distinction between the approximation and lower approximation. The lower approximation includes all the objects that can be classified surely based on the data collected, and the upper approximation contains all the objects that can be classified potentially based on the data collected. So here there are two different types of features as unnecessary features, namely row ID or customer ID. So and this is the target definition too. So redundant features are more difficult to eliminate because of the interactions between them. In order to reduce both kinds of unnecessary features to a minimum, the proposed parallel Rufset theory-based dimensionality reduction is optimized. And the big data consists of noise, stop words, special characters, etc. So these are all the most challenging to classify the data. So the collected big data is pre-processed to remove the noise, stop words, and special characters. The big data attributes are reduced using Rufset theory. A parallel Rufset theory for nonlinear dimension reduction in big data analysis has been proposed. So it is the approximation of vague set by a pair of concepts called upper approximation and lower approximation. So it describes the instances that sometimes belong to the possible subset. The lower approximation describes the domain instances. The main goal of every attribute reduction process is to identify the subset of attributes that maximizes between the class margins. So here a sigmoid function is used to calculate the inner and outer importance, where AK is considered as an attribute. CL cluster is a CL U of X red I of X is a certain set of red, and C is considered to be the conditional attribute set. So parallel Rufset theory-based dimensionality reduction, the lower and upper approximation can be defined as the following equation. So I of R is the equivalence class. So R of I and R alpha of I and R beta of I are the lower and upper approximation that is to be calculated. So these two are considered to be the Rufset. So the boundary of I is denoted by boundary region as R beta of I minus R alpha of I, which is called as the Rufset. So conditional attributes it is considered as C, and decision attributes it is termed as D. So positive region is to be considered as positive B of D, and positive region of C is considered to be positive C of D. So based on the preceding assumption, attribute reduction for multiple class of decision table are included with class tables. Finally, red returns the reduced attribute for target decision. So the time complexity for computing all granules is considered to be high by satisfying the requirement of efficient computation using big data. So here the MapReduce method involves the Rufset theory to reduce computational complexity. The parallel method is designed for the calculation of
join பண்ணு திருப்பி வாட்ஸ்அப் வெளியில வந்துட்டியா வாட்ஸ்அப்ல கனெக்ட் பண்ணி மெயில் ஓபன் பண்ணிருக்கியா மெயில் அனுப்பிச்சிருக்கேன் அப்படியே ஷேர் பண்ணி ஆரம்பிச்சு ஸ்க்ரீன் ஓப்பன் உள்ளுக்கு போன ஷேர் பண்ணி ஆரம்பிச்சு
MapReduce methods involves structure theory to reduce computational complexity. It includes 3 steps or map, reduce, and merge. Initially, the input big data are divided into blocks with a similar size and stored in different computing units. So map phase, each map worker partitions the attribute set, and in reducer phase, each reduce worker collects the data which own the same key. The red collects using attribute reduction algorithm for targetation, and merger phase, it collects the red from each reducer. As a result, the attributes in the data set are reduced using above parallel theory-based attribute reduction algorithm. So to classify the data, the reduced attributes are put into 3 different classifiers such as support vector mission, AdaBoost, and random forest. So this is the overall flow of proposed attribute reduction approach. Finally, the reduced attributes are given to 3 different classifiers. And the resultant discussion, the efficiency of existing singular value decomposition based attribute reduction and proposed paradox theory based attribute reduction are tested in terms of accuracy, precision, recall, and computation time. For the experimental purpose, 3 different types of data sets such as Amazon customer review data set, filter data set, and ICGC on AWS dataset has been used. So accuracy is a measure of correctly classifying the data based on reduced attributes in all instances. It is calculated by true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. The customer, the data set are given as the x-axis, whereas accuracy is measured in y-axis. So true positive is actually the positive data which are exactly classified as positives, and true negative is actual negative data which are classified exactly as negative, and false positive is known negative data which are wrongly classified as positive, and false negative is known as positive data which are wrongly classified as negatives. So the precision value is evaluated according to the relevant information of classification at true positive prediction by calculating true positive divided by true positive plus false negative. Whereas computation time is the amount of time taken by the reduced attributes to classify the data using classifiers. The computation time is shown using the bar charts. And the next research contribution to the next methodology is parallel semi-supervised big data clustering based on MapReduce technology. And this is also published in the Scopus journal. Introduction: big data brings tremendous challenges to extract valuable hidden knowledge, and the data mining techniques can be used over big data to extract relevant information for decisions, for making decisions. So, where big data consists of various interrelated kinds of objects such as text, images, audios, resulting in high heterogeneity in terms of structure form, and also big data consists of structured as well as unstructured data. So in this chapter, clustering techniques are introduced to separate objects into several groups. By using this clustering technique, it reduces the complexity for classifiers. By using PCM, that is probabilistic C-means algorithm, it is used to cluster the objects in the big data, whereas PCM, probabilistic C-means, is not more efficient for big data, and it cannot capture the complex correlation over heterogeneous data objects. So a parallel semi-supervised multi-and colonies clustering is introduced for data clustering. And one of the important clustering algorithms used to cluster the input data is probabilistic C-means clustering method, where each cluster in the probabilistic C-means clustering system is independent of other clusters, where it assigns or identify the noise points. So the input partitions for an n-dimensional dataset is assigned to describe various clusters, whereas the algorithm considers each entity that is similarly important to be part of clustering algorithm, whereas kernel-based probabilistic C-means algorithm are used to transfer original data into higher dimensional feature space. Probabilistic C-means algorithm perform well in clustering phase to achieve a clustering process with incomplete big sensor data due to missing value correction. So the suggested weighted, that is PCM algorithm, probabilistic C-means algorithm, requires partial distance to PCM. So to calculate the distance between 2 points in an incomplete data set, low weight values to incomplete data object to reduce missing value conception. So the main concept behind ant colony clustering algorithm is to randomly project onto a single plane where each ant chooses an object at random and picks up and moves and drops the object according to picking up or dropping probability based on the similarity of the object in the local region. Finally, clusters are collected from the single plane. The semi-supervised clustering algorithm collapses all the empire except the most powerful empire, and all colonies will be under the control of unique empire. So parallel semi-supervised multi-ant colony clustering is the implementation of semi-supervised multi-ant colony clustering algorithm in map-reducing concept. So the ant colony clustering algorithm is described by the following pseudocode, such as initialization, the number of ants to begin with, the total number of iterations, the local area sideline, the constant parameters, and the maximum speed. To project the data objects onto a single plane, that is given for each object at random pair of coordinates such as x and y, and each ant that is currently unloaded choose an object at a random. So each ant is assigned for a random speed. The picking up of probability is computed when the ant is unloaded, and the random probability, if the random probability is smaller, if it is not picked up by another ant at the same time, the ant picks it up and labels itself as an outlier. And when the ant is loaded, the dropping probability is computed. If the probability value is greater than the random probability, the ant drops the object, marked it as itself as unloaded, and it selects the new object. And if an object is isolated, it is classified as an outlier and assigns a cluster labeling number to this project and recursively assigns the same number to all the objects. And if any other outlier is found, it comes under the separate group as a local region. So objects with a greater degrees of similarity have greater values and tend to be clustered. The number of cluster decreases, the algorithm becomes faster. So if alpha is smaller, the objects have smaller degrees of similarity, and the larger group is split into smaller groups. Thus, the number of clusters will increase and the algorithms becomes slower. So objects which have a greater degree of resemblance will have the highest value and it gets started to a cluster. The algorithm gets quicker as reduction in the number of clusters occurs. So if alpha is lesser, the objects which have less degree of resemblance and a larger group can break into smaller groups. So finally, the number of cluster develops and algorithm works slower. The probabilistic conversion function. The function is derived and its purpose is to convert the average similarity for picking up and dropping probabilities. The following function is based on some criteria. Where similarity of data object is smaller, is picking up probability will be higher and dropping probability will be lower. So on the other hand, if the similarity is larger, picking up probability will be lower and dropping probability will be higher. So the probabilistic conversion function is expressed through sigmoid function. The above equation gives a slope constant. Cx is used to speed up the algorithm convergence when it is. So during the process of clustering, certain artifacts known as outliers, it has a high dissimilarity when compared to all other data elements. So the algorithm convergence can be slower due to lower outlier block ants. The greater parameter forces the ant to drop the outliers. The data points are uniformly projected onto a plane with a Cartesian grid in semi-supervised multi-ant colonies clustering. So each ant chooses a data object at random and picks it up and moves it. So or else it drops out and picking up or falling probability based on the similarity of the current data object within the local area. Here, when a square of H places surrounding place, P is denoted. So Q is termed as the ants. Q of maximum is denoted as the maximum speed of the ant to be moved. So the ants that moves faster speed groups approximately on large scale, while the ants that move slowly organizes the data item at smaller scales, positioning the object with a greater accuracy. So based on the different moments of the speed of the ants, three versions of clustering components are produced. As if Q is random, so Q is considered to be the ant. If it is random, then the speed of each ant is distributed randomly. And if Q is constant, all the ants in the population moves anywhere, whereas maintaining the same speed. When q is arbitrarily decreased, the speed term begins with a greater value, whereas the speed value is progressively decreased in a random manner. So the picking up probability is calculated as given as follows: 1 minus sigmoid function f of object I. So sigmoid function is used to guide the procedure of clustering towards a precise classification, where pairwise constraint in the parallel semi-supervised multi-and pluralized clustering is observed that the greater the resemblance of the data object, the greater the dropping down probability, and lower the picking up probability, as vice versa. So in order to decide the ants picking up or dropping out, here we will be considering two objects as must link and cannot link constraints are used. The two data objects should be in the same cluster as required for constraint, whereas the constraint, a couple of data objects cannot be in the same cluster. So NML, must link, user specified constraint. It implies that many data objects or belong to the same cluster in the specified data objects neighborhood, so that the ant drop down the data object. So NML greater than user specified constraint, it denotes the data object is unlikely to be in the neighborhood. So as a result, the ant must pick it up, move it to a new place. A hypergraph model is used to ensemble the clustering effects of various clustering models. So each row of matrix H corresponds to a data object, and each column corresponds to a hyper H, where it indicates that it is not or the data is unknown. And one indicates the vertex corresponding to the row belongs to the same cluster. So ML and CL are denoted as Mij equal to 0. So if Mij equal to 0, so the ant to be in the same class. If Mij equal to 1, the ant to be in the is likely to be in the same class. So the map automatically splits the big data object set into a number of partitions, and then each map function reads the content of the corresponding data split. The ant colony is initialized by assigning the location of every ant to be 0, 0, and the loading state L of I to be unloaded. So for each ant, the processor computes the number of places around it in the given region and finds the frequency of must link and cannot link constraints. When both the constraints fail to make a decision, that is ML and CL, the ant calculates the similarity of a data object within a local region, and the key value pair is as the output of the map procedure. And if ant is unloaded, then the picking up probability will be calculated. So the dropping probability is calculated when the ant is loaded. So if its value exceeds a statistical probability, the ant loses the data object, labels itself as unloaded, and randomly selects a new data object. The dropping probability is calculated when the ant is loaded. If its value exceeds a statistical probability, the ant loses the data object and randomly selects a new data object. When it is higher than a random probability, the data object is not picked up by other ants simultaneously, and labels itself as loaded, migrates the data objects to a new position. Otherwise, the ant does not choose this data object and instead chooses another data objects randomly. So it has been widely used to solve various types of optimization problems. So ICA begins imperialist competitive algorithm, begins with a base population. So in this algorithm, every member of the population is referred to as a country, and some of the best countries in the population are chosen to be imperialist countries, where the rest of the countries serving as colonies for these imperialists. So the workflow diagram of imperialist competitive algorithm, where initially the population is given random, and each of the object moves towards the imperialist colony. So if the cost of colony is higher than the imperialist, it follows by exchanging the position of the colony as in the imperialist, and it is again recalculated the cost function of all the empires. So finally, we will eliminate the worst empire. So the best empire will be the one empire. So So the modified imperialist competitive algorithm. So in this research work, a new mutation operator is proposed to increase the imperialist competitive algorithm convergence velocity and accuracy. And it can occur in variety of contexts, such as the population has converged on the objective functions called local optimum. The population's diversity has dropped significantly, and the search algorithm has progressed slowly or has not progressed at all. So, parallel semi-supervised multi-imperialist competitive algorithm is a method for clustering the big data based on ICA. Imperialist competitive algorithm, as like parallel semi-supervised multi-ant colonies clustering algorithm begins with an initial population called countries, which represents the data objects in big data. And any of the strongest countries in the population are selected as the imperialist, and rest of the objects are served as the colonies. So following the divisions of all colonies by imperialists, these colonies begin to move in their respective imperialist countries. And the overall strength of the empire is determined by the power of both colonial government and its colonies. So we compare will lose control and eventually will collapse. So the migration of colonies against are relevant to their imperialist. So the competition among empires will be collapsed. So, and again, map automatically splits the big object set into n splits. And the parallel semi-supervised multi-imperialist competitive algorithm begins with the initial country and select the countries with the lowest cost as imperialist. So the majority of the countries or colonies each belong to a different country, and the colonies are chosen randomly as transferred to their imperialist for the distribution of colonies among the imperialists. And the absorption policy is used for the imperialist countries to incorporate colonies into themselves. And the main core of parallel semi-supervised multi-imperialist clustering algorithm causing the countries to transmit their lowest optimal colonies. So to maximize the process of searching around the imperialist, a random number of deviations are added to the direction of movement. So the current location is achieved by deviating the country's previous location as defined in the random number with uniform distribution. So as the colony moves closer to imperialist countries, it may achieve a better position because the colony's position shifts depending on the imperialist position. The fragile empire will lose influence as a colony and result in the imperialist rivalry. It comes under the imperialist rivalry. So after a particular number of iteration, all the empires except the most powerful empire will collapse, and all the colonies under the control will form a unique empire. So, and this is the overall flow of proposed big data cluster. Parallel semi-supervised multi-ant colonies clustering algorithm is used to cluster the objects, and it splits into a number of partitions. The mappers are used for each partitions, whereas the two proposed algorithms are used to cluster. And and each mapper process the imperialist competitive algorithm and parallel semi-supervised multi-imperialist competitive algorithm. So finally, the clustered big data are processed using support vector mission, AdaBoost, and random forest to classify the data. So the results, result and discussion. So the effectiveness of the PCM parallel semi-supervised multi-ant colonies clustering and imperialist competitive algorithm are given under AdaBoost, support vector mission, and random forest classifier for 3 different data sets to test the accuracy, precision, recall, and computation time. So for experimental purpose, 3 different types of data sets has been given. So the accuracy is calculated by true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So, and precision value is evaluated according to the relevant information of classification at true positive prediction and false positive prediction, where it is calculated by true positive plus false negative. So it is given the results are analyzed through bar charts. So recall is evaluated according to the classification at true positive and false negative predictions. So the computation time is the amount of time taken by the reduced attributes to classify the big data classifiers. And the next methodology is big data classification based on forest deep neural network. And this is also published in Scopus indexed. Introduction. Big data analytics is the method of processing the large amount of data. The primary goal is to identify the hidden patterns and to generate new perspective on the future data. So data mining process such as attribute reduction, clustering, and classification are widely used to find the hidden patterns in the big data. Random forest based big data classification is not more efficient to handle the imbalance in big data. So here I proposed the ensemble random forest to handle the imbalance problem in big data. It also improves the performance of random forest classifier, and it is applied in each part of the data, and its classification results are combined through majority voting strategy. So forest deep neural network is proposed to improve the big data classification accuracy. So in a forest deep neural network, ERF and deep neural network are combined together for big data classification. So it detects ensemble random forest is called as forest, which detect the features in big data. So random forest is a combination of classification method by using one of the ensembled method. Random forest method will draw multiple training sample sets that are different from each other. Every single sample set builds a decision tree with the randomly selected attributes. So the growth process of a single decision tree in random forest is as follows. The original training sets called as bagging method is used to select random data with replacement and thus form training sets with difference. So the features are also selected using a sampling approach. All built decision trees will grow freely without pruning. So each decision tree will produce a result based on the input data. The integration of several outcomes will produce a random forest final output. The ensemble learning method is a mechanism that make predictions based on variety of different models. This ensemble model is very flexible and very less biased and less data sensitive. It has less uncertainty, and as a result of integrating individual models. So bagging and boosting are two most common ensemble approaches. So bagging is the process of training a large number of human models in parallel, whereas boosting is the process of sequentially training a large number of individual models. Significant algorithm is demonstrated at step 1 at random subsets, the training set is selected, and in step 2 the particular decision tree is trained. So one decision tree is trained using one random subset. So the optimal splits for each decision tree are determined by random subset features. So for example, 10 features in total, randomly we will select 5 out of 10. And each tree independently predicts the records or candidates in the test set. And finally, prediction is optimized. So detailed ERF is a machine learning technique where initially the big data is split into parts by using bootstrapping method. So this process is repeated n times to get a bootstrap data set. So to build a tree, ERF first creates a root node containing bootstrap sample. So the ERF ensemble random forest algorithm selects a random subset of data to search over and subsequently determines the best split based on splitting criterion. The splitting criterion maximizes some measures of node purity, which means the degree to which individuals of node belongs to one class. Here, Gini index is used for splitting criterion to choose the best split of each node. Well, it is one of the measure for potential split by separating the individuals into two known classes. So the Gini index is as calculated by using the formula, and it is the proportion of individuals that are of class C at node n. So it is used to minimize all the individuals in the node or of the same class, whereas it increases the individuals in the node are spread more evenly among different classes. So the gain for splitting the node based on data is defined as the difference between the impurity at node n and the weighted average of impurities at child node of n is given. So n to the power r, that is the right child, and n to the l is the left child, respectively. So these two are the proportions of individuals assigned to right and left child nodes. According to the gain value, the data with the lowest impurity is chosen to split individuals at node, and this process is continued until unpruned tree is found. Here in the above equation, n is the node and xi is the data. So considerably, we have two different parts in the forest deep neural network. So the forest components acts as a feature detector, learning sparse representation from raw inputs, and deep neural network component acts as a learner, predicting outcomes using new function representation. Forest deep neural network is used for big data classification to develop or to increase the accuracy of big data classification. It is a combination of forest and ensembled random forest and deep neural network parts, where forest part acts as a feature descriptor and DNN act as a learner. So in the forest part, forest is created using random forest and it acts as a feature descriptor. And FDNN part is a forest collection of decision trees. So ensembled random forest, ERF is termed as theta equal to theta 1 to theta t. So it is considered as a splitting variables of big data. So it is considered as an objective. So for the feature detection process, ERF is fitted by the training data. So ERF is classified, can be obtained using fitted forest. So here softmax function, G is calculated using DNN, which converts the value of the output layer into probability classification. So here the weight and bias are calculated using stochastic gradient descent by minimizing the following cross entropy loss function. The overall flow of the proposed big data classification. So by using ERF, it is used to class imbalance in big data. The clustered big data is split into different parts by using bootstrapping method. So the cluster data is sampled to reduce the class imbalance problem. So forest deep neural network is proposed to improve the accuracy. So to give the better accuracy result, FDNN uses ensembled random forest and deep neural network. Results and discussion. The performance of proposed big data classification based on ETRF and parallel semi-supervised FDNN is analyzed and compared with parallel theory in terms of accuracy, precision, recall, and computation time. For the experimental purpose, 3 different types of data sets has been used. So accuracy is a measure of correctly classifying the data based on the reduced attributes in all the instances. So and it is calculated as true positive plus true negative divided by true positive plus true negative plus false positives plus false negative. So precision value is evaluated according to the relevant information of classification and true positive prediction and false positive prediction. So it is calculated by true positive divided by true positive plus false positive. So recall is evaluated according to the classification at true positive and false negative predictions. Computation time is the amount of time taken by the reduced attributes to classify the data using classifiers, and the performance of parallel theory, parallel semi-supervised multi-imperialist competitive algorithm, random forest has been shown. The first phase of the research work, the parallel theory is proposed for the attribute reduction in big data. The input is given by the big data source, the MapReduce framework, so that the mappers reduces the splits the data into subdata. Parallel semi-supervised imperialist competitive algorithm is given by the ant colony clustering algorithm. Is based on imperialist competitive algorithm. So finally, the data clustering results are occurred by analyzing the input AdaBoost, support vector mission, and random forest for classifying the big data. So the efficient big data classifications are proposed by using ensembled random forest and forest deep neural network, whereas the class imbalance data problem is handled by ensembled random forest by using the process of bootstrapping and random sample for replacing the data from the original training set. So in future enhancement, the advanced security techniques will be proposed using dynamic data set, and the new mechanisms for big data security may be required to incorporate the new characteristics of big data like data pattern or data variation to ensure the real-time protection. And it's also very challenging due to its complexity and real-time processing demands of streaming data. So the new security technologies and tools are constructed for this mechanism, which will be analyzed. So these are all the list of publications. So I have published one journal in UGC index and the remaining 3 in this index. So these are all the papers which I have referenced for my research work.
Okay, thank you, Amsaveni, for your presentation. Audience and research scholars, any queries? You can raise your queries. Any queries from audience? Any questions? Anything you want to discuss? Current research scholars, Anand, Gauri, Lassi. Gauri, yeah, are you want to ask anything?
Sir, no, sir.
Okay. Geeta ma'am, any queries?
Scholars and students, you are encouraged to ask queries and you can participate in the discussion, ma. Any queries from our scholars? Okay, sir. Let me ask my queries, sir.
Yes, ma'am.
Amsaveni, it was a very good presentation, ma.
Mm,
Amsaveni, for the purpose of our scholars, can you explain what is an outlier with an example, ma? In slide number 86, you have mentioned outliers. You just go to slide number 86, ma. Yeah. Just explain,
outliers.
you just define an outlier, and in this particular example, how we are going to calculate the outliers, ma?
Outlier is considered to be not it does not occur in both of the classes. It gives it is meaningless. Outlier is considered to be meaningless, which does not comes under any of the class.
Okay, in this example, how you have calculated this outlier, ma, in this particular case?
We will be refining to be in both of the class, ma'am, so that lies out of the class, it is considered to be the outlier, ma'am, which belongs or which lie out of the boundary region are considered to be the outlier.
Sure, that is the definition, Amsaveni. My question is, with specific to this particular problem,
Okay, ma'am.
where was your outliers? Can you be
Outliers,
specific? Yeah, in this particular case, how was your outliers? Which cases or which data you consider as outliers?
outliers will be special characters, symbols that does not come give the similarity of the data, ma'am.
Okay, ma. Then we have heard about ant colony. In slide number 91, you have mentioned multi-ant colony. Can you throw some light on multi-ant colony, ma? What do you mean by multi-ant colony? Yeah.
And the objects we are placing on a single plane, ma'am. So where different ants or different objects will move to a class or clustered. The particular ant which does not belong to the cluster remain as to be outlier.
Can you differentiate between ant colony and this multi-ant colonies, ma?
Ant colony is a single ant that is considered to be the imperialist. So multi-ant colony is 2 or more colonies.
How they are forming their cluster, ma? On what basis the ants get clustered as groups? What is that big attribute or vital attribute that plays an important role in forming the multi-ant colonies, ma?
It is based on the data set, ma'am. If number of objects are greater or more, so it depends upon the ant or multi-ant, ma'am.
Actually, my question is how we are differentiating ant colony and the multi-ant colony. That was my question. Okay, ma. In slide numbers 134 and the previous cases, you have mentioned about computation time. Is it not, ma? Can we have the formula for the computation time, ma? Because it will be very useful. Because in the previous case also, you have compared based on the computation time. Is it not, ma? In the 3 contributions.
Yes, ma'am.
Slide number 134, and in the previous also you have mentioned the comparison was based on computation time. What is the formula for computation, ma? Because nowhere you have mentioned the formula for it.
Computation time
Ah.
equal to the time taken to process the whole data set, ma'am.
What is the formula? What are the parameters included in calculating the computation time, ma?
Then the only parameter is the time, ma'am. Here we used what we calculate is the time taken.
You are giving the definition, Amsaveni. My question is, what is the formula? Yeah, if the formula is mentioned, and then you can be specific to your problem. Okay, so it will be easy for others also to know about what is the formula for computation time. Okay, so whenever you are predicting these parameters, you do mention the formula, and then you can be specific to your problem. Okay. In slide number 61, you have mentioned a map reduce algorithm. Can you briefly describe what do you mean by map reduce algorithm, where it is used? Map reduce algorithm.
Map reducer algorithm is used in my first methodology, ma'am. So, so big data is considered to be the voluminous amount of data. A single processor will not accommodate all those data for processing, ma'am. So here we are implementing MapReduce technique where those big data is splitted into H blocks and given to the MapReducer where dimensions are reduced, ma'am, and it is collected using the attribute called red.
Is there any significance of using MapReduce algorithm or dimension reduction algorithm? Because in dimension reduction and in MapReduce, do you find any similarities, ma?
Yes, ma'am. In dimension reduction algorithm, we are using only we are involving only a single processor to accommodate all the data, whereas in MapReducer, number of map reducers with the processor are engaged for processing. H blocks of data are divided and given to each processor.
Okay, okay. Thank you, Amsaveni, for answering the queries. Okay, congratulations, ma. That's it from my side, ma. Thank you, ma. Thank you, sir.
Friends, any other queries? Otherwise, we'll rejoin again because it will get over and our external will ask the question. Callers, any queries? Surendran sir, if rejoin bent, then you can ask questions, sir, and we can conclude.
Okay, sir. The scholar is there, sir.
Yes, sir. Yes, sir. Yes, sir. சார் பிரின்சிபல் சார் கிட்ட ஒரு வேர்ட் கேட்டு அப்புறம் நம்ம கொரி பண்ணிக்கலாமா சார்? சுரேந்திரன் சார்.
Okay. Okay, sir. Okay.
பிரின்சிபல் சார் உங்களோட வார்த்தை சார்.
சார் நல்லா ப்ரெசென்ட் பண்ணாங்க. ஏன்னா நிறைய கொரிஸ் வராததுக்கான காரணமே அவங்களுடைய எக்ஸ்பிளனேஷன் கரெக்டாக இருக்குங்கிற மாதிரி தான் என்னுடைய கருத்தாக இருக்குங்க.
தேங்க்யூ சார். தேங்க்யூ சார். தேங்க்யூ. Surendran sir, you can ask.
Okay, sir. Amsaveni, good presentation.
Thank you, sir.
And you have done very good work and good publications. So I have only few queries. So here, after feature selection, why you need to go for clustering?
For clustering, sir.
Yeah. So you are doing clustering after feature selection, correct?
Yes, sir.
So why after feature selection, why clustering is required?
So without clustering, the attributes cannot be grouped. So we are going for it, sir. We cannot able to analyze or predict the data.
Okay. And why rough set theory is considered compared to other PC and filter other methods?
Subset theory is used mainly for classification, sir.
Okay. Now, why it is preferred compared to other methods? Why you are used to that one? Any justification for using rough set?
Rough set theory is mainly for small blocks of code can be constructed where it is used in the MapReducer, sir.
Okay. And in the second work, you have used feature selection, correct?
Yes,
So
sir.
how many features, original features are there, and how many reduced features?
Sir, you're asking about data sets, sir? Features.
Yeah.
Sir, moreover, overall, I have collected more than 5 lakh records, sir, and I have manipulated those records and filtered and fetched around 10,000 records, sir. And
Okay. Now what is?
totally, finally, 8 attributes I have refined, sir.
Okay. What is the training testing ratio? You have used the classification, correct? What is the
Yes, sir.
training testing ratio?
So 3:1, sir. 3:1, sir.
That is 70:30 or 60:40, or what is the ratio? That is the training testing
Sir,
ratio.
that is
This question I also asked in the comments.
so 30:40, sir.
30:40 will not become more. See, out of 100, how much you are
100,
used
sir.
for training and how much is for testing? Or you used
Sir,
cross code
70:30, sir. For 70:30, sir.
Yeah, that's we should tell immediately. You should not have things too much for this. Okay, so how many classes are there?
Totally 5 classes, sir.
Okay. Okay, well, that's all from my side. Good presentation. Sir, shall I conclude?
Yes, thanks, sir. Please, sir, declare.
Okay, sir. Okay. So today we witnessed Amsaveni's open different Viva voice. So she had presented very well, and she has very good publications. And based on her presentation and she answered the queries, the committee recommends for award of PhD degree to Ms. Amsaveni. So hereafter she will be called as Dr. M. Amsaveni. Congratulations, madam, and to her guide, docents are also.
Thank you, sir. Thank you for all attending the Viva examination. Once again, I am thanking all of you for joining this. Thank you.